Hello and welcome to my YouTube channel. Today in this video we are going to talk about real-time systems components and requirements. So let's start the video without any delay. To design a real-time system, we have to keep in mind some components. For example, every real-time system shall have timeliness output. It means whenever we are designing something, we have to get the output in a particular time, or we can say the ability to produce an expected result by a specific deadline. Similarly, second component or the most important component is the time synchronization. That is the ability of all the agents to coordinate independently with respect to the clock and to have a synchronized output at the end. Now, when evaluating a real-time system, the companies or the users generally measure the value of any system by checking how predictable the system is. Predictable here it means the output within a specific time period. The predictability can be measured in terms of first latency. Latency means how much time it takes for a task to enter into a system and generate an output within a specific time. Or we can say it is the measurement of time between two events. Then the second parameter is the jitter. That means how much latency is there between iterations. That means first assume a task took 2 milliseconds to complete its job. In the second iteration, suppose it takes 2.5 millisecond or 3 millisecond. Then in that case, we have to measure the jitter related to that particular function. So it is not necessary that all the functions will complete their job within a specified time period. So in such cases, we have to measure the jitter. Now, how can one guarantee the real-time behavior of any system? For that, first of all, avoid adding any unwanted feature to any system or equipment. And if you are designing any appliance for real-time applications, then avoid over complicating the system. For example, we have water geysers in our home. When we are going to take a bath, we can add so many features in a water geyser, but there are so many features which are totally unwanted. For example, adding voice command or might be displaying the outside weather or showing message received in your mobile phone. Such functionalities can be added to a water geyser, but the question is, do we have to add them, or do we have to overcomplicate or overkill the appliances that we are using in our day-to-day life? So we shall avoid unwanted features to any equipment. Second, avoid programming each and every instrument around. Sometimes if we are going to program each and every simple devices within a system, then we are again making a system very complicated, or we will be adding more and more delay in the overall system's output. For example, a car's windshield wiper. This can be designed using a simple motor. But if suppose we add this feature in microcontroller to check whether the wiper is in the left position or then the right position, at what speed the wiper is moving and so on, then based on that, we are actually further complicating a system, and we are delaying the other functionalities which may be there in the car, which may be very important in real time. Now, if a problem can be solved with the hardware alone, then explore such possibilities. What does that mean? Suppose if we can do a simple task using while loop or maybe using interrupts, and if that is giving us a required output, then we shall not go for real time operating systems to achieve the same goal, because again that will be a overkill of a simple problem. For example, what are the types of real time systems that we see around us? First category is called hard real time systems. Hard real time systems are those systems in which the system must meet the deadline 100% of time. You cannot miss even a single deadline. In such case, we will call it hard real time system. For example, if we are talking about medical devices such as pacemaker or car's airbag or missile system, we cannot miss even a single deadline in such instruments, because that will be totally catastrophic and may be fatal. So we shall avoid any delay in such system, and those systems are called hard real time systems. Then we have second category called firm real time systems. Such systems should meet their deadlines nearly all the time. It is not necessary that it should always 100% time it should meet the time or deadline. For example, such systems are video players, audio players, even forecast systems. Even if they miss maybe one or two of the outputs or deadlines, then in that case, it is not going to cause any catastrophic output, or it is not going to cause any fatality. In such cases, we may call them firm real time systems. Third category is soft real time system, where the system can continue to function even if it is not able to execute within an allotted time. So there is a flexibility that if the system achieves the output within time, it's okay. Even if it is not achieving the output within a specified time period, and still we can go with it, then we can call such systems soft real time systems. For example, web browsing and gaming. There may be times when web browsing takes some extra second, or maybe 2 or 3 extra seconds to generate the output, and that is not causing any harm to us. In such cases, we call the system to be soft real time system. There are many real time operating system providers or RTOS providers. Some of the most common and popular are listed here. Most of the RTOS listed here are paid, or we can say you have to subscribe them by paying some amount, or they are having some license fees. The RTOS which are with a yellow background are free in cost, and we can use them for free. In our course, we'll be focusing more on the free RTOS. These are the some of the RTOS which have the royalties allotted to them or not. For example, DOS is an operating system managed by DDC I company, we have to pay royalty if we are using this RTOS. Embed OS is provided by Segar and we don't have to pay any royalties for that. Similarly, FreeRTOS again is owned by Amazon, which is free, or we can say it is royalty free. We can use FreeRTOS without paying any license fee. Similarly, these are other operating systems in which we don't have to pay royalties. For example, Kyle, RTX, MQX provided by NXP, Nucleus provided by Mentor Graphics. Then we have Safe RTOS, which do not require any royalty. Then we have ThreadX, which do not require any royalty. Then a very commonly used operating system or FreeRTOS is Micro C operating system provided by Micrium, and it was actually acquired by Silicon Labs in 2016. It is also free to use. Then last but not the least, Zephyr provided by the Linux Foundation. All these RTOS are free and we can use them without paying any license fee. With this, I would like to end this presentation. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you can get the intimation or notification as soon as I upload a new video. If you have any suggestions or queries related to the video, then please share your comments and suggestions in the comment section. Thank you and have a nice day.